So here's our invariant checker for the class red-black tree. You want to make sure that the root node is black. You can make a mistake, say move that subtree up here, and all of a sudden the root becomes red. This assertion will take care of this. And as you can see here, we're setting up helper functions in order to break down the invariant into manageable small pieces. We want to make sure that there's no cycles in the tree. We want to make sure that pointers to parents are consistent. That is, if some node points to its parent, then it should also be a child of this very parent. We want to make sure that in both subtrees, the number of black nodes is equal. That's a nice, long function name which says it all. And finally, you want to make sure that red nodes have only black children. And at the same time, black nodes only have red children. Not sure whether we need to make this a separate method. Some of these checkers are rather trivial, that is one-liners. Others require traversal of the entire tree and would typically call themselves recursively. And now, for every single method that changes the state, you can now invoke the invariant checker. You do so at the beginning, you do so at the end, and when all of your assertions pass, then you can be sure that your red-black tree never ever becomes corrupted. However, if something goes wrong, you will get the error message at the very moment you make the red-black tree inconsistent. You will get the precise assertion that fails, and you won't implant any time bombs, because if the precondition is satisfied, and if the post-condition is violated, you know that it's precisely this method, the insert method in this case, that caused the data invariant to be violated. This thing about red-black trees actually is a sort of personal thing for me. 10 years ago, when I was a teaching assistant, my professor had the cool idea to have the students implement red-black trees as a programming exercise. And we, as teaching assistants, had the cool idea to come up with real hard automated testing for the student assignments, which turned out a disastrous combination. Because writing a red-black tree is one thing, writing a red-black tree that works is another. At this time, I did not really know how to debug. Neither did my students, and neither did my professor. So we, as teaching assistants, would be sitting with our students for hours and hours and hours in the night, stepping and stepping and stepping through the program and trying to figure out where on earth, on the umpteenth insert operation, this particular pointer would finally be moved to this other location, which was a total pain to figure out. In particular, with regular debuggers, you typically step over the whole thing and then finally lose the moment, so you'd have to restart again and restart again. And if I think about how many hours, probably days and weeks I have lost digging through these data structures, whereas with a single invariant checker, I could have found them in minutes, I'm still somewhat sorry.